Hello, everyone. Today we're going to be talking about we're going to be doing an introduction to Cloudbreak, the cloud provisioning tool for Hadoop. So, basically, we're going to cover the tool, the architecture, do a demo, and save some time for Q&A. Next slide, please. So, as a reminder to everyone, this presentation will contain some information about products and technologies which are under development. And, the discussion of these features and technologies is not a commitment or promise or obligation from Hortonworks to deliver these features. So the direction is subject to change. But with that, next slide, please. My name is Jeff Sposetti, and I'm a product manager here at Hortonworks, and I'm responsible for a few parts of the Hortonworks data platform, and I focus primarily on the operational pieces. So that's Apache Ambari, Cloudbreak, and I also am a committer on the Apache Ambari project. And today I'm joined with Janos Matjas, who's the former CTO and co-founder of Sequence IQ. And Sequence IQ is the company that created Cloudbreak, and Sequence IQ recently became part of Hortonworks. And so in Janos' new role at Hortonworks, he's a senior member of the engineering team, driving the development and delivery of Cloudbreak. So next slide, please. So for today's agenda, we'll cover a few things. We'll start off with some background on Hadoop Everywhere, and we'll give an overview of the Cloudbreak product. And then Janos is going to get under the covers a bit and talk about the technology and what makes up Cloudbreak. And then he's going to give you a demonstration of Cloudbreak so you can actually see it in action. And then we'll leave some time at the end for some questions and answers. So we'll move quickly. So the phone lines are muted, but you can text your questions via chat, via the BrightTalk chat session. So you can post those there, and we'll respond to those at the end during the Q&A session. So with that, let's get started. So, as it gets to thinking about the idea of Hadoop Everywhere, and when we really step back and look at the market for Hadoop and the adoption of Hadoop Everywhere, there's really a few things that need to happen. Hadoop needs to handle any application, any data, and be able to do it anywhere. So traditional Hadoop was, limited to an architecture that focused on batch applications and a single data set. But Yarn has transformed how Hadoop works and has enabled really any application to leverage the power of Hadoop. And so Yarn enables batch, interactive, real-time applications to run simultaneously on shared data sets. And, basically, really that makes it possible to bring different workloads and different engines and really any application onto the platform. And when it comes to any data, there's really the process has always been there, and a core objective has always been there for the enterprises to bring any data into the platform. So before Yarn, traditional Hadoop platforms really, how they handled different data sets and how they managed and governed those was really kind of different across the board. But with Yarn, it's really made it easier for enterprises to manage, govern, and secure new data sets, traditional data sets, regardless of where they're coming from. And so that's really kind of enabled the middle tier there for any data. And then the third leg of this is really about anywhere. So it means that Hadoop can really be integrated and be deployed anywhere inside of your enterprise. So you have architectural platform of choice. You have support for Linux and Windows, whether you're using commodity servers or appliances, and then really the ability to handle cloud platforms. So whether you're talking Azure, Google Compute Engine, Amazon Web Services, OpenStack as a choice of a private cloud, where you really want to have it everywhere. So, having these three pillars handled really enables Hadoop to be able to deliver and deployed for any application, any data set anywhere. Next slide, please. And so when it comes to that anywhere decision, it's kind of the question of where should it be, up there or down here? Should it be up in the cloud or should it be down in my data center? And so when you kind of step back and think of a swath of use cases, it really kind of depends. It's really not about one or the other. It's really about having the choice. And so regardless of the use case, really the question gets to, looking at the use case, thinking about the sensitivity of the data, where the data comes from, how it's going to be used, who the audience is. So, it's really not about should you do it in cloud or should you do it on-prem. It's really about having both choices. So if you go to the next slide, please. It really gets to have it everywhere and really have your choice. And so you want to make sure you have a hybrid deployment choice, so you can run on the Linux, Windows, or on-prem or in cloud. You have a choice that gives you that flexibility, that then you can also make sure those clusters are compatible with each other so they can process and handle the same workloads. And then you also need to be able to handle replicating data sets across those different clusters, since they'll be both cloud and on-prem. And so we're not going to spend much time talking about replicated data sets in this session, but I will encourage you to go check out the Apache Falcon project, which is a framework for handling data replication and pipeline processing. Next slide, please. So kind of with that laid out, let's actually dive into Cloudbreak itself. Next slide. So Cloudbreak is an open source tool for being able to spin up and manage multiple clusters that are deployed into cloud environments. And it provides a mechanism for people to automate and manage the full life cycle of their Hadoop cluster in a cloud platform. Next slide. So, and there's actually animation, so if you click again. So as you use Cloudbreak, you have the ability to use a blueprint which defines, how a cluster will look and what engines it will have available and how they actually are put together in the cluster. And then you're actually able to give that to Cloudbreak. Choose your cloud, so you can choose whether it's the public clouds like Azure or Amazon or Google, or even your private cloud of your own OpenStack deployment, to say this is where I want that cluster to exist. And then you can actually go and launch it, and Cloudbreak will be able to do that for you. Next slide. And once those clusters are actually put in place, and those clusters, have been deployed and are being, and are accessible from Cloudbreak, you actually have the ability to auto-scale. And so you can set up policies under which scenarios, which alerts, which metrics, and getting feedback from Yarn as well to be able to decide, there's times to scale up or scale down the cluster. So Cloudbreak also helps simplify that task for you. Next slide, please. So, I've kind of said it, hinted at it a few different times when we're talking about clouds. We are talking about public and private clouds. So in the public case, it's your Microsoft Azures, your Amazon Web Services, your Google Cloud Platform. And in the private cloud case, we're talking about, OpenStack, where you actually have an OpenStack deployment in your data center. But really, fundamentally what Cloudbreak provides is the ability to have a cloud provider, and then these implementations are put in place so that you can use Cloudbreak and actually handle working with any of these choice of clouds. Next slide, please. So what does the process look like to go and provision a cluster in the cloud with Cloudbreak? So there's a few different steps we can break it down into. One is creating the templates and making those templates available to Cloudbreak. And templates really talk about what's available in your cloud in terms of resources. So what types of machines and where are they located and their networking. And Janis is going to go into this a lot more detail, but that's effectively what the template does. And then the blueprint is how your components will be laid out in the cluster and what workload you're expecting to be able to run on that cluster. And then, of course, we need a way to actually talk to your cloud provider. So, there has to be some credential support. And then once you have those three things in place, then you can put them all together and ask Cloudbreak to launch the cluster. Next slide, please. So quick look at creating template. So this gives you the opportunity to, choose your cloud and what resources are available. So from a central place, you can actually manage the resources that are available from your cloud provider. Next slide. Then the blueprint, you give one or more blueprints to Cloudbreak, so where you've defined the different components, the different services, the different parts of Hadoop that are available, and you tell Cloudbreak about those things so that it knows what type of Hadoop clusters you plan on deploying with which engines. Next slide, please. And then you tell it about the credentials. So how does it actually talk to Amazon Web Services or Google Compute or Azure or OpenStack? So you give it the credentials it needs to be able to go talk to the infrastructure. Next slide. And then you go and say, put all three together and launch a cluster. So I expect to use this blueprint against this cloud using these resources, and go put that cluster together for me. And that's, effectively the high-level picture of what Cloudbreak does to be able to provision the cluster. Next step, please. So when you actually push that button, a little more details. It actually goes and talks to the cloud provider to make VMs available and prepares them for Docker because, ultimately, Cloudbreak is actually going to deploy the cluster in these containers, and Janos goes into this in a lot more detail later on. Then it actually, bootstraps those Docker containers so that they know how to, discover services between them as well as network using some technologies that Janos is going to talk about, like Swarm and Consul. Then, a big piece of Cloudbreak is actually powered by Apache Ambari. So, Cloudbreak then installs Ambari onto those machines and actually makes sure it's available to be used. And then using the blueprint, Cloudbreak gives that blueprint to Ambari, and it goes and lays down the Hadoop cluster on the resources that were provisioned. So that's the high-level flow from the user experience of being able to go from templates, blueprints, resources to a cluster, and this is what Cloudbreak does after you finally launch the cluster. Next slide, please. From a auto-scaling perspective, once the cluster is actually up and running, there's the concept of being able to scale the cluster. So you can actually get metrics and alerts from, different parts of the system. So whether they're from Yarn or from Ambari itself, you can actually set up policies in Cloudbreak to say, based on different alerts or metrics, what should I do with the cluster? That could be expand, that could be contract. Gives you that option to do that. Next slide, please. And actually, pause for a second. I do see a question on chat that they're not seeing slides. I don't know if anyone else can confirm if they are or not. I don't know if it's broadly an issue or not. But I'll keep watching chat. Please reply if other people are not seeing slides. From an auto-scaling perspective, so you define the alerts, you set up the policies, so you're able to choose the different metric the alert will fire off of. Then you're able to actually set up the policy to respond to that alert. So what should it do? How should it scale the cluster? Should it do it based on, a percentage of the cluster should grow or shrink, or should it do it on absolute numbers? There's a lot of flexibility there, and Janos will get into that in more detail. But at a high level, you're able to actually define these alerts and the policies that respond to them to be able to handle scaling. Next slide, please. Okay, good. Other folks have replied they're seeing slides, so that's good. From an auto-scaling perspective, once you actually have the alerts and the policies in place, you're actually, what Cloudbreak does is watching for those alerts and watching for the metrics that you've asked it to look for. And so as the alert comes along, basically it sits there and, manages the cluster size, and based on the SLA you set up with the policy, will orchestrate a scale up and scale down. So it will go and talk to the cloud provider and allocate more resources, and then expand the cluster by asking Ambari to put Hadoop components on it as necessary, as well as do the opposite if it's a shrinking type scenario. Next slide, please. So, I've shown a few different slides here that had screenshots, and that's the Cloudbreak UI. There's also two other mechanisms to be able to talk to Cloudbreak, whether you're going to manage the templates or blueprints or your credentials or clusters. There's a REST API that's available from the Cloudbreak server, so you can actually, do some of the things that we showed in the screens via the REST API. And then there's also a shell that's available. So from command line, you can actually manage templates and credentials and blueprints and clusters. So there's actually some resources available out on the public Cloudbreak and SequenceIQ site that you can go check out the documentation on these. And we can actually go and at the end, we'll actually give you these links plus others to go check out. Next slide, please. So that's kind of the high-level picture. Basically what I want to do now is hand it over to Janos, who will go a little bit deeper into the architecture of Cloudbreak and how it uses the different components to pull off the cluster provisioning and scaling, and then he'll actually go into a demo as well. So take it away.
Thank you, Jeff. Good morning, everybody. So when we started to work on Cloudbreak, we've been provisioning Hadoop clusters pretty much on any cloud environments and physical hardware as well, and we needed a way to be able to provision these clusters using the same API across all these different platforms. There were a couple of challenges and steps we needed to be repeated on every cloud platform. Every cloud platform has a proprietary API. You would need to build images for every cloud provider based on already available ones. Then you have network issues like multicast is not available usually in cloud providers. Then you need, especially for Hadoop and Ambari services, you need a DNS. Then also there are other things like moving parts, like you need a service discovery, service registry, because as our clusters we've been always thinking of auto-scaling clusters. Things are pretty dynamic, and in a cloud environment, you don't know anything beforehand, so we needed something where we are able to discover and register services and auto-scaling. So having said that, Cloudbreak basically is doing the heavy lifting for all these things. So Cloudbreak is separated on doing a couple of things. First of all, it relies, as just specified, just mentioned, it relies on Ambari to do all the Hadoop management and Hadoop services configuration and provisioning using the built-in Ambari metrics and alerts as well. Also for describing your Hadoop cluster architecture relies on Ambari blueprints. Then we've got an abstracted API which abstracts all the major cloud providers, Azure, Google, Amazon, OpenStack, and actually there is a plugin mechanism available. There is a service provider interface where you can plug your own proprietary cloud provider. There are a couple of other cloud providers might be able. They are going to be plugged. But as I said, there is an SPA interface you can use to plug your own provider. Now, if you move to the building blocks, so I should separate them two different things. So we've got the infrastructure part, which first of all, in order to have a Hadoop cluster, we need to have a working infrastructure, whether those are physical machines or cloud VMs. Then you've got the Hadoop part itself. So for Hadoop part, it's pretty easy. The standard provisioning of Hadoop services is Apache Ambari, and for monitoring as well. For infrastructure, as we want to come up with a seamless solution across every platform, so actually working even on physical hardware, we started to use Docker. So Docker is a piece of new technology, not that new, but recently it's pretty high. So all the Hadoop services were running inside Docker containers. We use Swarm in order to orchestrate these containers remotely and spin up these containers across different machines, VMs, and also we use Consul for service registry and discovery. So what Docker is pretty much, it's like a container-based virtualization. you can think of like an extremely lightweight and portable VM. It's pretty easy to package applications because it's using a layered file system. For us, it was pretty appealing that it can be automated and scripted, the whole process. And also, all the processes running in the containers are isolated. Pretty much all the containers are isolated from each other, but the big difference between a VM and the Docker container is that containers actually, they are sharing OS libraries. So instead of having a host OS and then on top of the host OS you've got a guest OS and emulated hardware, a hypervisor, with Docker you don't need all these things. Actually, the only thing you need is the Docker daemon running on your host OS. And once you spin up containers, your containers actually are acting exactly like your VMs, but they save you lots of resources. They can save up to 20% of resources at least. So this is the Docker part. Now we are running HDP and Ambari inside Docker containers. Now we need to push these Docker containers to different VMs and different machines. So for that we use Swarm. So Swarm, it's native clustering for Docker, and what gives us is basically the distributed container orchestration. So we can orchestrate all these containers remotely. We can push these containers, and the nice thing with that is that it works the same way locally as remotely, because Swarm is using has the same API as Docker. So there is no difference whether we are spinning up something locally on my machine or on my laptop or remotely on a physical server or a cloud VM. The API always constantly stays the same. Swarm has managers and agents running on these nodes, and when you spin up these containers, obviously you need to know about each other. So for this we use there is a service. You need to have a discovery service. Since we use Consul anyway, in our case for Docker, we use Consul as well for discovery services. And the other nice thing with Swarm is that you have advanced scheduling. So you got a set of machines. In our case for Cloudbreak is VMs, but actually, as I said, can be physical hardware as well. You can schedule different containers on these machines with Swarm, and you can schedule based on different strategies. You can do random. You can do beam packing. Also, you can apply filters, you can apply affinity, constraint-based filters. You can also do all these things by hairs or label-based. So, for example, if you've got VMs or you've got machines, you can label them like high CPU, and you know that if you need a container which requires high CPU, then actually it's going to be scheduled on those particular nodes. So these are one of the main features of Swarm as well. So we briefly talked about Consul. So Consul is the service discovery registry for us, but beside that, actually there is it has a key value store as well. So, or if you want to share some values across the cluster, we can use the key value stores. The nice thing is that it also gives us DNS. So previous versions of Cloudbreak were using surf and the DNS masks. Now Consul altogether gives us this feature. Also, it's data center aware, so if you can actually spin up a cluster across different data centers. So, like any other CAP systems or flavors, basically it's using a REST protocol. It needs a quorum to operate, for example, like Zookeeper. So for that, it uses a REST protocol. Also, it's based on servers and agents. The big difference between others is that Consul actually is using a stream protocol, which is a gossip-based protocol. It's not, for example, heartbeat based. It's decentralized and fault tolerant, and it's highly available. One of the nice features as well is that you can have different interfaces to inquire about the services. You can have a REST API through an HTTP interface, but actually we have a DNS interface, and you can use BIG to inquire about services. So all the services we are starting, like for example the Ambari, where are the for us, we don't configure anything beforehand because on the cloud you don't know, and actually we don't really care. We just register all the services in Consul. And if one of the applications needs a service, Like for example, I need to know where the Ambari server is running, or I need a database service. I specify the details. I just query console where the service is running, and I got the service endpoint. So we've got different applications and different moving components, but they don't really know about each other. It's nothing hard-coded. The only way how they communicate and the only way how they figure out where that service actually is available is the entire console. There is another nice feature of console support for watches. So you can watch for different changes on the key value store, and this way Cloudbreak has another feature which is called Cloudbreak Receive. So you can push pre and post cluster configurations into your Cloudbreak cluster using watches. And yeah, the heavy lifting in Hadoop side, now we got a working infrastructure is done by Apache Ambari. Ambari basically is the way to provision Hadoop clusters in a very easy way using the blueprints. So one of the key features are blueprints. Also, it gives you management and monitoring options. It uses a REST API, so Ambari has a UI as well, like Cloudbreak. It has a secure REST API, and also has a CLI shell. So actually, this was one of our first contributions to Apache Ambari, the Ambari shell. It's extensible, so you can define different stacks, services, and view. Also, it has a new feature called Ambari Views. So how Ambari pretty much works like all the systems before. It's based on a server and agent-based architecture. It's not that hard to use. Basically, once you got a blueprint JSON which describes your Hadoop services, then you got a host map. You do your host mapping and you specify which services you want to run on which host. This is actually automated for you by Cloudbreak. And once you post the cluster create, then Ambari starts provisioning the cluster. There are a couple of Docker containers for Cloudbreak internals. So how Cloudbreak actually consists. So you got a VM or you got a physical hardware where you got a Docker daemon running. So that's our only requirement. Everywhere where a Docker daemon is running, we can provision an HDP cluster consistently using the same Cloudbreak API or CLI or UI. For us, there is no difference. The only requirement for us is to have Docker available. Now we got a couple of infrastructure containers like console, registrator, and ambassador. So registrator is listening on the Docker socket, and once the container is started up, we just register those containers into console, and we rely on ambassador to do cross-host container linking. There are a couple of database containers using Postgre. Actually, you can change it, and at the higher level, you got the Cloudbreak application itself. Cloudbreak application, it's a Spring Boot application written in Java. Exposes a REST API and also a shell, which is based on Spring Shell. Now we got another component called Periscope, which is actually monitoring through Ambari the HDP cluster and gives based on the SLA policies you have configured, it does the auto-scaling. Cloudbreak itself is secured there are multiple levels of security, but at the API level, it's using OAuth 2 and constitute an identity provider. For by default, if you don't use CloudFoundry's UA, you can change, if you got your internal OAuth 2 server, then you can change it. And then on the top, you got the user management, which is called Sultans, and Uluwatu, which is the Cloudbreak UI. So these are the key components of Cloudbreak. Actually, the whole process. So if you are about to deploy Cloudbreak on on-prem, it's all automated. So we got a Cloudbreak deployer tool. In 3 minutes, again, you don't need anything but a Docker daemon. You got a Cloudbreak deployment locally. You can always use the hosted solution as well. So let me switch with this to the demo. So this is the Cloudbreak UI, Uluwatu, which I'm showing you. So Jeff briefly mentioned, I'm going to walk through all these main building components. So obviously, in order to provision a VM in order to provision a Hadoop cluster, you need a couple of VMs running your cloud environment. So in order to talk with a cloud provider, you need to have credentials. The nice thing about Cloudbreak is that actually in none of the cloud providers, we are not asking for your username password. The control is never on the Cloudbreak side. The only thing we are asking from your side is to provide an association between Cloudbreak and your cloud provider account. So this is something which we call credentials. They are not really credentials, but these are actually an association between Cloudbreak and the cloud provider. So we don't ask you for your username password in case of Amazon or secret key or something like that. So you can create your role RM on your cloud provider side, or you can use our script to associate that everything is automated. And then the only thing you need to paste in Cloudbreak is this role. You can always terminate the role on the cloud provider side. We are not going to be able to launch more instances. Actually, Cloudbreak launches instances on your behalf. Another thing is that Cloudbreak never asks for a public key from you in order for you. Obviously, you got a private side of the key. This is the key you are going to use to be able to SSH into your provisioned VMs. Again, we don't have any access. Cloudbreak can't SSH or can't do anything with those VMs besides provisioning. Business is done. So these are the credential stuff. We got something which are called templates. So templates are basically your infrastructure, are describing your infrastructure. Since, as Jeff mentioned, since Yarn, the work on the Hadoop cluster actually has changed. You got different systems, you got different applications running, and all these applications are requiring different instance types. So Cloudbreak gives you the option to provision not homogeneous clusters, but actually you can provision heterogeneous clusters, and every Hadoop service you provision with Cloudbreak, you can specify the instance types or the configuration you want to have. So for example, if you use Kafka, then you can choose an instance type which is has high I/O throughput. If you use maybe a legacy MapReduce, then you want to have an instance type which gives you a large CPU. All these things can be configured on templates. Obviously, you can configure the number of volumes you want to attach per instance, the volume sizes. You can choose between SSD, magnetic, and ephemeral kind of volumes. For those cloud providers who support spot prices, then you can specify your spot price, and we try to launch the cluster with the given spot price. Also, we feature encryption, so you can encrypt your data volumes. These are pretty much the configurations for regarding templates. Now, templates are describing your infrastructure. Besides your infrastructure, many people they already have in a cloud provider. Many people they already have a pre-configured network. Cloudbreak gives you the option to either create a network configuration based on your needs, or actually you can reuse. If you want a pre-configured VPC, then you can reuse that. And Cloudbreak can launch clusters on your already existing VPC. Which means if we don't have to create clusters. If you don't specify a VPC, then Cloudbreak is going to create a default isolated. So every cluster is going to be instantiated in an isolated VPC. So these are the networking parts. The final piece is blueprints. So blueprints are basically these are unburied blueprints. So there is no difference between this blueprint and unburied blueprint. Actually, you can see, so I'm checking this blueprint. You can go to raw view. This is a JSON file. Actually, you can see the layout from host group base. So, for example, this blueprint has 4 master host groups, and you see what are the services available on those Hadoop services available on those host groups. There is a gateway host group and a slave host group. So these are the unburied blueprints. Now, once you got all these things, actually the only thing you can what you can do is like you can provision, you can create a cluster on your favorite cloud provider. So I'm going to choose, for example, I want to create a cluster on Azure. Just click create cluster. You can specify the region. We support all the regions for all cloud providers. So you specify the region where you want to launch your cluster. You can specify your network. You choose your blueprint. Choose the HTTP multi-node blueprint. You see we parse, and we realize how many host groups you have in a body blueprint. You can specify the number of instances you want to put on the blueprint. Cloudbreak does support AJ blueprints. You can use you can add multiple host groups. You can add multiple instances for master host groups, slave host groups. I can add as many as I wish. Instance types. Actually, well, this is something which I was showing you templates. So if I have multiple templates, then you can create a Hadoop cluster based on different templates, different instance types, different number of disks, things like that. Also, we got something like called advanced options. So if you switch to advanced options, there are a couple of provisioning configurations. So, for example, in many cases on a cloud provider, when, for example, we are asking for a 2,000 node cluster, maybe the cloud provider on that particular region is extremely busy and is going to be able to give you 1,800 nodes. What are you going to do? So you can have with Cloudbreak, you can say like, okay, I would like to stick with an exact number. If I choose exact, though I specify 2,000, I can say, yeah, whatever. If it gives me only 80% of 2,000, then I still want to launch my cluster. Or you can specify exact number of nodes. Also, you can specify best effort. Best effort means, yeah, maybe the cloud provider is going to give you, instead of 200, you requested 2,000, but it's going to give you 1,000. You say, okay, I'm still fine with that. I want to launch and create my cluster. The final thing you need to do is just say create and start a cluster. But all the other features are the auto-scaling. Yeah, just one more thing. So, for example, when you start launching a cluster, there is an event history which you can track. You can see the cloud descriptions, the nodes available on this cluster, the templates used for each and every host group. So the master host group was built on this template, GCP Medium. Actually, I built this all on the same template. You can always check the blueprint and the credential you have used. Once the cluster is provisioned, actually, everything is business as usual. So you can always go to Apache UI and you can manage your cluster using Apache. So this is the cluster which I just provisioned with Cloudbreak on Google Cloud. So there are no differences between a cluster being provisioned with Cloudbreak or manually or using Apache. So you got the auto-scaling. So auto-scaling, we rely on Apache and Apache Yarn to monitor and get out metrics from your cluster. We collect approximately 400 metrics. Basically, we collect all the Hadoop metrics available. Without using any, you don't need to pre-configure anything. You don't need to install anything. Just the only thing you need to say is to enable your auto-scaling SLA policies. And in a couple of seconds, Cloudbreak with Periscope now is going to be able to, it's attached to your cluster using Apache and Yarn, and now it's pulling these metrics. So you can create alarms. Alarms basically are metric-based ones. So we got two kinds of alarms, metric and time-based. Let me show you the metric-based ones first. So as I said, we collect around 400 metrics based on the services you are running in your cluster. We pull the metrics. Obviously, if your cluster doesn't have Kafka, we are not going to show you Kafka metrics because it makes no sense. So these are the metrics available for this cluster I provisioned. You can select all the metrics. You can choose the state of the metric. All these things like number-wise can be configured using Apache and Apache, actually. And then you can specify the period for how long you would like to this metric to be this alarm, for how long this metric has to be sustained in order for this alarm to be triggered. So obviously in production clusters you need to set up something more than one. In this case, I'll just create 1 minute. Now then you got, so I got an alarm configured. I can create, based on these alarms, I can create as many alarms as I wish, but based on these alarms, I can create scaling adjustments. So for example, I say, yeah, okay, I want to increase my cluster size with 10 nodes, or actually you can do by percentage, or you say exact number of nodes, exact cluster size. And as I said, we support heterogeneous clusters. So for example, if you've got a cluster architecture which contains Spark in a host group and contains Kafka in another host group and also contains MapReduce, you don't necessarily have to upscale all the cluster because it doesn't make really sense. You actually want to upscale the services which are requiring resources. So we give you the granularity to scale only those services which actually are on demand. That's the same value for downscale. And then you choose the alarm and then create a policy, and that's it. Pretty much that's it. Now I just push an upscale policy to the cluster. On a production cluster, obviously you might want to limit scaling adjustments. As you see, that alarm which I just configured has been maintained for 1 minute, and now I started to provision nodes. So there is a cooldown time, so you can lock down your cluster for scaling between. You can specify a cooldown time, and within those minutes, your cluster is not going to be upscale and downscale. It makes no sense in a production cluster to, for example, upscale, downscale every 5 minutes, because maybe there is a spike, a CPU spike or whatever metric you configured, and you do a scaling event. You might want to lock it for a while. Also, you can specify the minimum boundaries of the cluster size. So Cloudbreak and Periscope is not going to shrink or increase the cluster above these specific numbers. So you can configure this as well. As you have seen, basically what we request that alarm has been triggered. There was a scaling policy, and now I'm adding eight new instances to this to the cluster infrastructure. You are going to be able to track to Cloudbreak, and then you should be able to monitor with FireBar that actually those services are getting installed on the particular cluster. Also, Cloudbreak gives you a couple of features, like you got inbuilt account management. So basically, you can manage users, you can invite users under your account. You might have seen there were things like public key accounts, so you can create templates, credentials, and make it public within your account for the users you have invited under your account. You also have you can get account details. Actually, there's a usage explorer. So based on the filters, actually you can generate usage explorer. So you can see that, yeah, these are the clusters I launched on these cloud environments, for how long they are running. You can get the combined hours. So actually you can filter this down by to the region, user, or whatever. So you can track down your costs, cloud provider cost through Cloudbreak as well. I think pretty much that's the Cloudbreak demonstration. So I switch back to the slides.
Cool.
And with that, I give you back Jeff the control.
No, awesome, really cool. So yeah, you covered a lot of ground there. That was really good to see it all and hit all those features. So a lot of questions came in, and we'll get to those in just a few minutes. So that's kind of the wrap up here, and kind of highlight a few things. So as part of the Cloudbreak itself today is actually available in open source. So the Sequence IQ folks have prior to being acquired by Hortonworks had the Cloudbreak code and those things out there as part of their GitHub in open source. And what we look to do here at Hortonworks is help submit that to Apache Software Foundation for incubation, and really drive they'd be to see the Cloudbreak 1.0 release actually focus a lot on public cloud providers. So really the Azure, the Google Compute Engine, and the Amazon Web Services as those providers. and make those the highlight of the GA release of the first 1.0 of Cloudbreak. And we look to, make the Cloudbreak available as part of Hortonworks Enterprise Plus subscription. And, as, these things kind of like move forward in the meantime, if you need help or have questions about Cloudbreak, we have launched a forum on the Hortonworks forums. So you can go there to kind of like ask questions in the community and, get help if you need any help. Next slide, please. And then some other resources to get started. So obviously, as the project is in the open source under GitHub, you can go check out the code there at the SequenceIQ Cloudbreak GitHub repository. You can also check out the SequenceIQ website that has information on, Cloudbreak, so it covers the features and things like that. Right now, there is a hosted Cloudbreak trial, so that you can actually go and try out Cloudbreak that's being hosted and, enter the information about your public cloud provider and kind of launch up some clusters and see how that goes. And then there's also a little quick start to say, well, now I want to actually go and take Cloudbreak and get it installed and try it out. So it actually walks you through getting the code, getting the product, launching your own Cloudbreak server, and kind of running from there. And again, as you're going through all those things, jump into the Hortonworks forums if you have questions or are looking for assistance there. Next slide, please. So we'll open it up here. Janos, I'll cover some of the questions that came in. So the first one was, actually I'll take this first one, and then we'll kind of go down the list. So a question came in about the blueprints, and could they be built or created out of an existing cluster? And so the answer there is, so the blueprint format and actually, the way that all comes together is really based on Ambari blueprints. So, you can effectively, get a blueprint from a running cluster that is being managed by Ambari. So you can actually export a blueprint from a cluster. And then that blueprint can become a blueprint you reuse to actually go and create clusters from it. So the blueprint model, you obviously can create them on your own. And there's a couple that are preloaded in Cloudbreak when you get it. And there's kind of a lot of blueprints showing up, in the community. But being able to get a blueprint out of a running cluster is available as it's really exporting a blueprint from an Apache Ambari managed cluster. The next question that came in, so Janos, question came in, does Cloudbreak application itself run on a Docker container? So I don't know if you want to talk a little bit about the Cloudbreak server itself.
Yeah, so the Cloudbreak application, if I go back a few slides, so basically this is what you see. This is the Cloudbreak application itself. They are all running inside Cloudbreak containers. So if you check the CBD deployer, so if you go to our GitHub, there is a tool called Cloudbreak deployer that actually we have automated the whole provisioning and configuring Cloudbreak. Everything is Dockerized, not just the Hadoop ecosystem, but actually the Cloudbreak application itself is running in Docker containers as well. So the short answer is yes, and you can give it a try. If you got a Docker daemon running, actually Cloudbreak deployer helps you with that as well. But once you got a Docker daemon running, then you can have your own deployment of Cloudbreak in around 3 minutes.
Cool. Kind of a follow-on to that. So, when it comes to all the components and services of Hadoop, they're launched in Docker containers. Is that correct?
Yes.
Yep.
So all the HTTP services are launched actually inside the Ambari Docker container, and that's one of the key reasons for us why it's so easy for us to move these containers between different VMs across different platforms, and actually even long-term be able to join, for example, config hybrid cloud or things like that, because everything is running inside the container. So we are not worried about packaging and all that stuff. The only thing we carry is the container itself. And that's why for us it's so easy to deal with these complex infrastructures in a unified way.
And follow on to that is, when it goes in provisions, is it a VM per machine and that runs a Docker container for each agent, or is it a single machine with all Docker containers and all agents?
Yes, a good question. So the Docker containers are running with net equal host. So initially we were experimenting a lot around, say, one VM running multiple Docker containers. But there are a couple of things. First, in that case, you are going to need a bridge network, which adds some overhead. So performance-wise is not the best option. The second thing is, in terms of Hadoop, actually the only thing you care are the number of yarn containers. So it doesn't matter if you've got a VM with certain resources and you split in one large Docker container or 6 smaller Docker containers. At the end, the resources are the same, and yarn cares about the underlying resources. So you are not going to gain any throughput. It's just things are going to get complex, and because you need to use a bridge network. Obviously, you can always change. So Cloudbreak would be able to basically, if you want to change that, you can do it. The code is open source, the configuration is there, it's open source, but actually we suggest to use one Docker container per VM currently. And there are several reasons for that as well, like all the major cloud providers. Amazon is a good example, but Azure is an example. OpenStack is a good example as well. They are all moving towards the direction that actually through their API you are going to be able to span containers directly. So there is not going to be there is no need for VMs, because actually you can spin up containers directly. There are most of the cloud providers, they give you this as a private option. For example, as I said, in OpenStack there are several solutions: the Nova Docker driver, the Ironic HP Ironic driver. So you actually, I assume, in a couple of years, you don't really need VMs because you are going to be able to run containers directly. You can do it even now, and this is the direction. This is one of the directions we are going, and also with running only these things on Docker containers, actually you are going to be able to provision with Cloudbreak the same way HDP on bare metal as well, if you wish. So short answer again is we use Docker with net equal host, and it's one container per VM or one container per host.
Okay. So if you can switch back to the slide with the links, the kind of get started links.
Yeah.
There we go. Cool. Oh, it's the last one. Right there. Cool. Awesome. So folks can kind of grab those while we, next question was around, when it comes to running on Docker, any security concerns about Docker, container boundaries, anything like that?
Yeah, so the container, so currently the biggest security boundary around the class provision cluster is obviously the first of all, is given by your VM. So you use a VPC with your virtual private cloud where you spin up your instances, the whole cluster is locked down. And actually, since Cloudbreak and the containers are using the host network and also using the volumes from the host, basically inherits the same security as you have configured on your cloud provider. So by default, Cloudbreak actually locks down the whole cluster on the cloud provider. There is a new feature coming called security groups, where actually you've got a very restricted security group where nothing is open, but you can only SSH on your box, and there is a less restrictive, but always you can create your own security group. So there are no security concerns around this running in Docker.
Cool. There was a question around networking. I think he touched on this a little bit, but the question was supporting dynamic DNS, custom NTP, and really the bootstrap process.
Yeah, so the bootstrap process actually is done by the project we open source is called Münchhausen. So we got the Scratch 22 problem. So in order to spin up a Docker cluster, you need a service discovery, but for us, since everything is in a Docker container, console is running a Docker container, there is no service discovery. So we needed to fix this problem, and we fixed this with a project called Münchhausen. It's available on GitHub. Now, regarding the networking, so for us, DNS is given dynamically by console. So that was one of the key reasons why we switched from serve DNS masks to console, because we rely on the dynamic DNS given us by console.
And the last question, what about, when it comes to custom images, or can you use some type of local Cloudbreak repo for images?
Yeah, so currently the hosted solution is built on CentOS-based images, but actually any cloud image can be used which has a kernel which does support Docker. So if you take Cloudbreak and the deployer, actually you can see that you can configure the VM. You can configure the AMI, and you can start off from that. So basically, there is no requirements. There are a couple of packer scripts if you want to build your custom VM. Actually, we can help you with that. We can give you all the automated scripts. But bottom line is that Cloudbreak actually doesn't require anything fancy on the VM. The only thing it does require is a Docker daemon running. So any base image which is able to run Docker, and pretty much these days all the images are able to do that, you can use as a start image. So there are no requirements. What we suggest though many times is like HDP. There are a couple of OSs which are supported by HDP. So you should choose something. It's not mandatory, but ideally on the host you should have the same OS as you are running inside the container, and that OS has to be supported by HDP.
Yeah, that's a good point there. So yeah, so it is. So as Cloudbreak, once it has VMs in the containers and it puts Ambari on there and puts HDP on there, it is kind of the HDP running on those machines, and that's where the requirements come for the OS from a guest OS perspective. But otherwise, you're pretty. It sounds like you're pretty vanilla when it comes to images themselves. You just need to be able to handle Docker. So, I think that's kind of where we are. We're almost up against time here. I'd really like to thank Janos for driving through the architecture and the demo and answering all the questions here. And thank everybody for joining and participating and asking the questions. So this recording will become available. So you'll be able to get the recording and see this content. So I think it becomes available off of the same link you used to join this live webinar. I think it becomes available from that, and really we'll kind of go from there. So I encourage you to check out some of the resources that are available, the overview of Cloudbreak, try the hosted trial, check out the code, try the quick start, and if you have any questions, drive into the Hortonworks forums and ask there about Cloudbreak. So thanks everybody. We'll wrap up the webinar now. Cheers.
Thank you. Bye.